Okay, so looking here, so at 2015 question 10a. Firstly, you are asked to distinguish between saturated and unsaturated. So saturated contains all single bonds. Unsaturated contains double or triple bonds. Okay, so you have to explain both there. In 1865 then, Auguste Kekule proposed the structure for benzene shown on the right. How many pi electrons are there in benzene? So first thing I'm going to have a look at, now you wouldn't have to go into this detail in an exam, but I am just going to explain it a little bit here. So benzene has a formula of C6H6. Okay. What I'm looking at here is carbon. Okay, carbon has an atomic number of 6 and a mass number of 12. So that means it has 6 protons, and in every neutral atom I have the same number of protons as electrons. So if I'm to write my one electronic configuration, 1s2, 2s2, 2p2. And I'm looking here at my 2p orbital, and remember this is split into 2px, 2py and 2pz. Okay, so if we just look, remember my electrons must occupy orbitals singly before filling them in pairs. So this is what I have. If I look at my 2px orbital, these lie, p is dumbbell, so they lie flat on the plane, and we have an overlap here in line with my nucleus, so that's a sigma bond. However, if I look at my 2py orbital, okay, what I have is my overlap here, not in line. Okay, so that means that these are pi bonds. Okay, you're asked then, how many pi electrons are there in benzene? I have 6 carbons. Each of these carbons have 1 pi bond. Okay, 1 pi bond, 1 in the py orbital. So in total, I have 6 pi electrons. Okay, now all you have to do is write in 6 pi electrons. Sorry, I just forgot this up here as well. Describe how you would test a given hydrocarbon for unsaturation. So red, yellow colour of bromine water turns colourless. Okay, so red, yellow colour of bromine water turns colourless. I just forgot that little part of the question. Next then you're asked, explain whether or not the Kekule structure, which is what we have here, correctly describes, firstly, the number of electrons. Okay, so if I look, this does describe correctly the number of electrons. Okay, so just if I was to draw this out, one carbon double bonded to another carbon, single bonded to another carbon, double bonded to another carbon, single bonded to a single carbon, double bonded to carbon, single bonded to another carbon. And remember, H6, so each one of these have 1 coming off it. If I look, each of these carbons have 4 electrons. Okay, so you're asked in the question, explain whether or not the Kekule structure correctly describes the number. So yes, it does describe the number. Why? Because each carbon, so you're asked to explain, so each carbon has still 3 sigma and 1 pi bond. Okay, so just if we look at this, this is a sigma bond, this is a sigma bond, sigma bond, sigma bond, and always the double bond here is going to be my carbon double bond. If I look here, sigma, 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 1 pi bond. Sigma, 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 this carbon, 3 sigmas, 1 pi. Likewise here, 3 sigmas, 1 pi, 3 sigmas, 1 pi, and this carbon, 3 sigmas and 1 pi. Again, this is all you need to state. It does because each carbon has 3 sigma and 1 pi bonds. The next thing then that you're asked is, does this Kekule structure correctly describe the distribution of those electrons? And the answer to this is no. Okay, and the reason why is because in benzene they don't form alternative double bonds. What happens is the electrons are delocalized. Okay, so remember when I'm drawing benzene, and if I look at this structure here, it would indicate a highly reactive, very unstable, unsaturated compound or molecule. It is none of those things. It is very stable, it is very unreactive, and it does not decolorize bromine water. Okay, so this structure is incorrect in its distribution because my electrons are delocalized, which means they are not attached to any one particular carbon. Instead, they are found in the ring here. The final part of the question then you're asked is, give one piece of experimental evidence in support of your explanation. And I've actually just said that, okay? So the reason why, the biggest one, is that it does not decolorize bromine water. Okay, if the Kekule structure was correct, it should decolorize. It doesn't. Okay, there's also loads of other ones. The carbon to carbon bonds in benzene are of the same length. Okay, again, there is a value for a single bond and a value for a double bond. The benzene bonds are all in the same length, so they don't have a value for a double bond or the single bond. The carbon to carbon bonds are also intermediate, so they're between a single and double bond. Okay, so they're not a value for a single or a double bond, instead they're a value in between those. Okay, finally, or the next thing, again, benzene is stable, unreactive. Okay, that would also get you your marks. There's loads of examples there, but they are the biggest ones.